Problem 2 is about the finding the payback period. Two equivalent pieces of farm equipment are being considered for purchase, and we have the table there. Machine 2 is expected to be versatile and technologically advanced enough to provide income longer than Machine 1. And you can see Machine 2 is 15 years, Machine 1 is 7 years useful life. And the minimum attractive rate of return more equal to 12%. And the question is now find out the what should be the payback period for machine 1 and machine 2. So which one is more recover the initial investment faster? If you go to the just previous video, go over the concept of payback period. I just quickly showed you the definition. So estimated time an alternative will take for the revenue and benefit to recover the initial investment and stated return. And one thing that we will show you, the payback period should never be used as the sole measure of growth to select alternative, and that realized in this problem too. So and to find the NP, we set NPV n star equal to 0, and just similar to the IRR analysis, internal rate of return, we should set NPV I star equals 0. Now it's instead of I star, we put N star for the payback period. So let's go back to here. We have initial costs for machine 1, machine 2, annual income, and the maximum useful life. So on way first, we draw the diagram for this one. So let's draw the diagram for each machine 1 and machine 2. And then you can see for machine 1, if the cost, initial cost 12,000, going down 12,000. And then we have here the annual income 3,000. So income go up. And for 7 years, so let's put the time scale 1, 2, 3, 4, 5, 6, 7, 7 years. And the time scale is years, that for machine 1, 3,000. 1, 2, 3, 4, 5, 6, 7. 3,000 per year. And that is machine 1. And then similarly, we have machine number 2. Years, and the life is 15 years. So we have 0 and 15 years. So 15, 5, 10, 15 years. For the first 5 years, it's 1,000 benefit, and the initial cost is 8,000. So here 8,000 initial cost, 1,000 for the first 5 years for the benefit. For the annual income, 1,000. So you see 1,000 per year. And then from year 6 to 15, 3,000. $3,000 per year. And this is machine number 2. And now we want to know which machine get the shorter payback period. One is shorter. So to find, and you can see from the note, to find, just remind here, to find NP, then we have NP equal to N star, and we set NPV, the net present value, with the unknown N star, N star, and equal to 0. And we ignore the cash flow after NP. And with that, we want to see the machine 1, what is the payback period N star for NPV, and machine 2. So let with that, with the machine A or machine 1, with the machine number 1, we set the NPV. So we have the NPV 1 and N star for machine 1, as you can see in here. It equal to, from the cash flow that you see, yeah, it equal to negative 12,000, 3,000 for certain years. We see N star, so here positive 3,000, and we have the factor given annual amount, want to find out NPV at type 0. So we have given A5P P over A. The MAR, the problem with us, is 12%, as you can see there. So it will be 12%. So instead of NPV method, we put that is 7 years for N. But in this case, we want to find out how long will it take to return the money, the initial investment 12,000, and that instead of put 7 years in here, 7 years, we basically erase that and we put the N star, so become an unknown, and we set yes equal to 0. So just like IRR method, but instead of put the I star in 12%, we put the N star for the N. And then we can plug the equation to solve for N star. How? Then we plug the equation of P over A 12% N star, and then use your calculator. So let me write down here. It equal to negative 12,000, and we plug that ratio, the factor, that factor P over A 12% N star, and go back to your reference, and given A5P, given A5P, and that equation that you have here, draw the 2A given P, we have that equation. So I, 1 plus I power N, 1 plus I power N minus 1. So go back to here. We have I, 12%, 1 plus I power N, 1 plus power N. In this case, N star. N star. And over 1 plus I power N minus 1. So we have 1 plus 12 power N, in this case, N star, and then minus 1. And it equal to 0. And this equation, one unknown in N star, you can use your calculator. Okay, use your calculator. And by now you should be able to do that. Otherwise, practice. Use your calculator so you can have this one, the end net present value, the n star here, it equal to about 7.8 years. Let's write down the year. Years, and that is actually the n star that we are looking at, and net present value, NP of alternative one that we have. So from that, as you can see, what does that mean? 7.8 years. It means that for machine one, to return the initial investment for 12,000, and with the stated return 12%, we need 7.8 years. So that after 7.8 years, that money is yours. That's the extra benefit we have. But after before 5.8 years, you have not returned your initial investment and stated return yet. So that basically the payback period for one. So that you have there. And then similarly, we want to find out the machine number two. Similarly, we want to have a machine two. And now quickly we can set the NPV2, net present value for machine 2, and that is n star 2 equal to, for our cash flow, 8,000 negative, 1,000 and 3,000. And yes, a little bit tricky here, so we have to observe. And you can see the first 5 years, we have the benefit annual income at 1,000 per year, without consider the time value of money. The first 5 years, without consider time value of money, we only have the income at 5,000, and your costs, initial cost is 8,000. So it means that the payback period for machine 2 cannot be 5 years or earlier, because after 5 years, without consider time value of money, only 5,000. If you consider time value of money, bring that 1,000 each year for 5 years, 2 times 0, it will be much less than 5,000. Because the money in the future, it will be less value than the money now. That's why if you bring 1,000 back, it here. So it cannot be 5 years. Now, how about 6 years? If it's 6 years, then what happened? 6 years here. So if it's 6, so 5 years here, 6 years there. If it's 6, so we have 5 without consider time value of money. You have the first 5 years, 5,000. 6 years, year 6 is 3,000, so 8,000. Bring 2 times 0, it less than 8,000. So it have to be, and you can see the net present value, the payback period have to be after year 6, for machine 2. Okay, so with that, we can bypass the first 5 years. So with that here, we can see the right equation down. It's negative. So that's very important. 8,000 plus 1,000 in the first 5 years. So P over A, 12%. Let me write another color for this factor so that we can easy to differentiate. P over A, 12%, and 5 years, not N star, because the N star is after. What does that mean? The N star is somewhere here that we want to find out. Where is N P after year 6? NP after year 6. Then for 3,000, study first 3 years, and after that 1,000, we 1,000, if we have 3,000, so we can have add 3,000, and of course we have P over A 12%. Let's write down, go down to here so that we can have space to work with. We add 3,000 P over A P over A 12%, and this is a little bit tricky here. What is that n star? N star, if you put n star, it then the 3,000 go from year 1 to NP. But here the 3,000 start at 0 at year 6. So we have to subtract the first 5 years that we already account in P over A 12% 5. So that one have to be, as you can see, N star 2 minus 5. The first 5 year already considered. The first 5 year already considered. So we have that minus 5 in there. And that's not enough. Yes, P over A 12% and to P. Remember, the P over A located one period prior to the first A. The first A at year 6. The first A at year 6. That P over A 12% N star 2 minus 5 located one period prior to the first A. First 3,000 is 6. So that ratio start at 5, located at 5. And then we have to print that factor from year 5 to year 0. And that it will be one future value print to present value. We have to put another factor, print that money. And you can see, yes, I make a note here. Yes, go back to at year 5. We have to print back 2 times 0. So we have a factor here given f at year 5, 2 times 0. So we have it f given f 5p 12% 5, and this is, we can say that print to present. It means 0 0. Make sense? And that we set it equal to 0. Equal to 0. And then we just plug in the equation with your calculator and go into find out. So equation now, and you can see with the reference, exam 2 reference. So we have that NPV 2 and 2 star equal to 8K plus 1K. That factor already know P over A 12% 5. So you can have that is P over A 12% 5. Let's go down to here. For 12%. 12% here. P over A 5 years. That you already have that factor. 3.6048. So we have that is 3.6048 plus 3K, and that factor now we can plug in with the P over 8, something similar to the equation here. So we can have That factor equal to 0.12, 1 plus I, 0.12 over n in this case n star 2 minus 5. So that the key point, because that n in this case the n star 2 minus 5 over 1 plus I power n minus 1. So in this case we can have that is 1 plus I 0.12 power n here n star 2 minus 5, and then we minus 1 from the equation. So that is the first factor. And now P over F, 12% 5. So given P, it should be opposite. We already know it, bring from year 5 to time 0. So it should be given F 5P, not given P 5F. Change that for me there. Given P, given F 5P, because year 5, that is future value. So F now, we want to bring to time 0. We want to find P. So given F 5P, if you go to the reference, go to the for 5 years. So given F 5P, so we have that factor is 0.5674. So that will be that factor time point 0.564 and set it equal to 0. And as you can see, only one and only n star 2. So with your calculator, use your calculator. Then we can find out the n star 2 equal to 8.3 years. And that basically it equal to NP of machine 2. NP of machine 2. So what we can say about this? The machine 1, it takes 5.8 years to get the return, the initial investment. The machine 2, it takes 8.3 years to return your initial investment. So it takes longer for machine 2. So if you see that here, everyone want to return the money faster. So you will choose, if with the this method alone, you will choose the machine 1 because it returns faster. Actually, it's faster 2.5 years, as you can see there. So you will choose machine 1. But let's go to the note. We go to the note here that show you the second note. The payback period should never be used as the sole measure of the growth to select alternative. And now I want to explain you why. If we use payback period as the single method to solve, then with this problem, and you can see now, we will choose machine 1. However, we should not use that alone to justify that machine 1. And you can see here from the cash flow. It takes 5.8 years for machine 1. So at the end, as you can see there, the remaining amount left is only 6,000, year 6 and year 7, as you can see there. Now for machine 2, the payback period 8.3 years. Then it's 8.3 years, so let's put 8 here. And you can see 7. So 8.3. So we have the money left is a lot. It's tremendous. From year 9 to year 15. So basically have 3 for 6 years. So it means 18,000. Compared to machines 1, only 3,000 for 2 years, year 6 and year 7. For that reason, as you can see, this method ignore the cash flow after the payback period, as they write down there here in the note. Ignore the cash flow after payback period, and that's the problem, because here if we choose machine 1, we ignore the more benefit after the payback period for machine 2. So that's why normally payback period should not be used as sole measure of growth to evaluate alternative. They need to use this method with other 3 methods that we already discussed: net present value (NPV), internal rate of return analysis (IRR), or benefit cost analysis. So for that reason, keep that in mind why it's not used as the sole measure of growth to evaluate the project using a loan payback period.